Hello students. So far we have been talking about current and current density, drift, conventional current, drift velocity. We found the relation between the current and the drift velocity. So and also in last class we talked about the Ohm's law, resistance, resistivity, right? So let us move on to find out the relation between the drift velocity, resistivity, length, electric field, current density and the potential. So moving on to this topic, let me tell you about the vector form of Ohm's law, because scalar form of Ohm's law already you are familiar with, which is V is equal to IR. So what is the vector form of Ohm's law, or how to define the vector form of Ohm's law? So for that, let me take the current density, which is equivalent of NE VD, shall I? Because current we know that, which is NEAVD. So just by dividing the area, we have the current density, which is NEVD, shall we? Already we obtained the VD value, which is NE A times tau. Right, we defined this drift velocity as A times tau. So A is nothing but F by M. Instead of F, I'm going to substitute E by M, shall we? So now I'm getting the current density value, which is N E square capital E tau divided by M. Can you see? These are all constants. N is a constant, E, tau by M, everything is a constant. This constant I'm going to call as another constant, which is sigma times E. You know, current density, which is a vector, and electric field, which is also basically vector, which is also proportional to this, with a constant. I have removed with a constant. So altogether I am going to call this as a vector form of Ohm's law. And I'll tell you what is this, because you know what current density is and what electric field is. Let me tell you what this sigma is. Sigma is nothing but, already we learned about resistivity, right? So this is inversely proportional to the resistivity of the material. So it tells you that, for example, conductance we are going to define, which is reciprocal of the resistance, and similarly resistivity ki conductivity sigma I'm going to define it, right? So now instead, so as I said earlier, let me erase this. So J is equal to, let me use a pen. So J is equal to, we obtain sigma times E. Instead of sigma, I can write 1 by rho times E J, shall we? So rho can be written as E by J, shall we? So now what I'm going to do is, that is what this PPT will tells us, right? Let us get into it. So rho is equal to E by J, right? Just now before we defined it. And instead of J, I'm going to define as NEVD. So let me write the expression in terms of VD, shall we? So VD is nothing but E divided by NE rho, shall we? Instead of electric field, I'm going to substitute voltage by L, because V by L. This is how we defined it, right? So now we are having the drift velocity in terms of potential, in terms of rho, in terms of N and E. Shall I tell like that? Now from this expression, I can tell that, so once, if you say this VD, the drift velocity is directly proportional to the potential, and also it is inversely proportional to the length, and it is inversely proportional to the resistivity of the material as well. So once you are increasing the temperature, let's say I'm increasing the temperature of a conductor. So because of the thermal agitations, collisions will become more frequent. So the average time, the tau, which that tells you the successive collisions between the lattice and the electron becomes decreases. So hence, if tau becomes decreases, correspondingly tau, you know, VD is directly proportional to tau, because nothing but VD we defined just now before A times tau. If tau is less, correspondingly this VD becomes less. If VD becomes less, what will you have? What will happen? Can you see this 1 by rho? This is 1 by rho. This is VD is equal to V by NE rho L. Instead of 1 by rho, I can write sigma V by NEL, shall I? So since the sigma, conductivity of the material, is directly proportional to the drift velocity, as you decrease the tau, there is a decrease in the value of the drift velocity. At the same time, the conductivity reduces. Is that clear? At the same time, resistivity increases. This is what the first point says. When temperature increases, VD decreases, because conductivity is also decreases, but that is inversely proportional to the rho, that is resistivity. So resistivity of the material increases. Correspondingly, when the length increases, VD decreases. When it get decreased, VD get increased. Inversely proportionality, right? So because of this, I am going to define conductance just now before we said, which is reciprocal of resistance, and resistivity reciprocal conductivity. So the temperature depends on the resistance. So once you decrease the temperature or increase the temperature, correspondingly your resistivity, what's happened? number of collisions because of the internal energy and the relaxation time decreases, so therefore the conductivity or conductance will get reduced, at the same time resistance and resistivity will get increased. Is it clear? Right. So the temperature coefficient of resistance which we can express, so for a particular material, if a particular material எடுக்கிற conductivity and property நான் படிக்கணும் அப்படின்னா, this tells you how much the electric field or the corresponding current will respond to. So this alpha, which is basically a temperature coefficient of resistance, that tells you that the difference in the resistance value divided by the resistance into the time will give you the corresponding alpha value. In terms of absolute values எடுத்தனா or not அப்படின்னு சொல்லுவேன், இல்லனா R1 R2ல நான் சொல்லுவேன். That's the difference. So absolute values in the sense 0 degree or T degree, இல்லனா especially we can have the two temperature differences as well. So that time the generalized formula for the temperature coefficient of resistance which can be obtained by this formula. Now let us moving on to the color code. So why it is very essential to have a color code? Because resistance of different values are commercially available, right? So to make a resistor, we have to take a carbon with a suitable binding agent that should be molded into a cylinder. So wire leads has to be attached to the cylinder. So entire resistor has to be enhanced in a ceramic or a metallic jacket, so that two leads which will connect the resistor to the given circuit. So these resistors are basically widely used in the electronic circuits such as radios, amplifiers. There are many examples we can have. So how to determine the value of the resistance? Because you know, in case of different circuits, we need different values of resistance. We will not stick with a single value of resistance, right? So in order to differentiate, or in order to have a easy way of picking the resistance value, we have something called as a color code. So how can we tell the color code, or how to define it? Just let's take a resistor. Let's assume this is the resistor. The first two rings from the end will give you the corresponding two significant figures of the resistors in ohm. Let's say BV. That will gives you the first B and B will gives you the corresponding significant figures. And the third indicates the decimal multiplier. Again we have a B, that may be a black, first one is a brown, right? So that will indicate the decimal multiplier that will comes in a power, right? And the last one will indicate the tolerance in percentage. So how much the tolerance you can give. If you give more than that, it will not work, or it may you know, the more large amount of current will pass through it. So this is where the tolerance come through the last part. So yes, mathematically we can express as AB, which is the first two significant figures, into the decimal multiplier plus or minus the tolerance value in terms of ohm. Is that clear? This is how we represent. So in order to have a color code, we have something called as a starting from black, brown, red, orange, yellow, green, blue, violet, gray, white, and tolerance we have is simply gold, silver. Sometimes we don't have color itself. Simply once you see there is no color, just you have to put the tolerance as 20%. That is what given here. So the number is assigned as, for a black we assign the number 0, for a brown it is 1, red 2, something it goes, so on so forth it goes on. So the letter corresponding will be B. First letter we usually take B. Roy, Great Britain had a very good wife. Just to remember that, let us see. So for example, we obtain, for example, let's say B, gold we have. So the corresponding the numbers you have to pick from the table, just you have to substitute it and you can have the answer. Similarly, we have GRB, silver. So we have this as 52 into 10 power 6 plus or minus 10%. Similarly, you have another one which you don't have any color. So just you have to write to plus or minus 20. So the term, or you have to remember like B. Roy, Great Britain had a very good wife. You can assume like this, just by taking the first letters of the given word, right? Moving on to next one, we are going to see the series combination of resistors. Why do we want to see the series combination? Because in electrical circuits we don't have only single resistors, we have a multiple resistors we have to work with. So correspondingly, how will you connect the resistors is also matters. How will you connect them, like a end to end, or like you know how to they are connecting. Let's say for I'm connecting through a series and I connect பண்றேன் அப்படினா total effective resistance or total equivalent resistance எனக்கு increase or decrease ஆகுதா அப்படிங்கறத நம்ம பார்க்கலாம். So in case we have a resistance which I am connecting with the end to end connection நான் connect பண்றேன் அப்படினா each have a different values of resistance, each will have a different potential differences, but all the resistance will have the same current. The effective resistance will be sum of the individual resistance. So total R is greater than sum of all the resistance அப்படி நம்ம சொல்லலாம். Once if I connect them parallelly, in them let's say if I am connecting with the parallel, potential remains the same, at the same time I'll have a different color, so sorry different current. So the total or effective resistance turns out to be 1 by R, which is 1 by R1 plus 1 by R2 plus 1 by R3. Simply it goes on so on so forth it goes. But here the R will be which is less than the individual R நமக்கு இருக்கும், right? So this is what about the series and then the parallel connection. Now let us talk about the sources of EMF. So what's basically this EMF is? It's basically an electromotive force. For example, if I have a battery, once there is a potential difference, if there is no potential difference at all, you cannot have the current, right? This is what we have learned in the current, electricity, and also we gave some information about this in electrostatics as well. So let's say we have a battery over here which we have connected with some electrical circuit, let's say resistor, or it could be a capacitor, whatever it is. But once if there is a potential difference across these points only, then we have a current which is passing through this resistor, you know that, right? But in order to maintain the constant potential, that one who maintains the potential, constant potential across the terminal of the battery is nothing but the EMF. Just a minute. It's nothing but the EMF of the battery, or EMF we can call. So EMF is the electromotive force, which we can define electromotive force simply as work done by unit charge. What does that mean? Abdina, let's say we have a charge over here. Charges will always move from positive terminal to negative terminal, but once it reaches the negative terminal, it will not have enough energy to reach the higher potential. Let's say the spontaneous process, let's say the waterfall, or once you fill the tank will overflow after once it fills up the entire tank, right? So once when the spontaneous process எல்லாமே higher to lower தான் நடக்கும். But once the water reaches the ground, you have to have some equipment or electronic instrument like a motor. You have to, like using that external device only you can make that water to go in the, or to fill the tank, right? So similarly, once the electron reaches, it can able to reach the lower potential, but once it reaches the potential, the battery has to do work, so which pushes each charges to the higher terminal. That is the EMF job, which pushes the charges to the higher terminal. That is work done per unit charge. Is that clear? This is what I am telling about the source of the EMF. அப்படி நம்ம சொல்லலாம். How come this is different from the potential? அப்படிங்கிறதையும் நம்ம இங்கே பார்க்க போகிறோம். Electromotive force is the maximum potential difference between two electrodes of a cell when no current has been drawn from the cell. Exactly, I can give the definition like this. So I am going to tell you the difference between the EMF and the potential difference. EMF have the maximum value, but the potential difference is any two point in the closed circuit. Let me have a resistance. We have a resistance which are connected in a series connection. We have a battery here. This EMF is the maximum between these two terminals, right? But here, even if it is work for an open circuit as well, it does not have any value change. But this potential is the potential between these two terminals, right? If these two closed, 2 points in the closed circuit, or 2 points in any given electrical equipment. So this is what the potential difference is. Now, the second point tells you that it is independent of the resistance, but potential difference obviously it depends on the resistance. EMF is only used for the source. இங்கே it is measured for the any 2 points. As I said, 2 resistance இருந்ததுலே அந்த மாதிரி நம்ம எங்கே வேணாலும் அதை measure பண்ணலாம். So it is greater than the potential difference between any 2 points, but it is always எப்படி இருக்கும்? Potential difference is greater than EMF when the cells are being charged, but that will not be always a case, but you can tell that the potential difference may be less than the EMF value, right? So this is what we can tell the difference between the EMF and the potential difference. Now let us move on to the Kirchhoff law. So Kirchhoff law is easy way to get the answer. In case if you don't see any kind of a series or parallel connection, if you see a symmetrical circuit, you can use the Kirchhoff laws. These two laws are very helpful to find out the equivalent circuit, equivalent resistance or current or potential, anything else, right? So let us talk about the first law. So the first law, or more precisely we can call this as a junction law or junction rule, so which tells you that or which talks about the conservation of charge. No charges will sit or accumulate at any particular point. Incoming current should be equal to outgoing current. This is what conservation tells us, right? So first law talks about the conservation of charges, that tells you that any charges which is incoming should be equivalent of outgoing charges. So or yet I can define in the another way, like algebraic sum of electric currents at any junction turns out to be 0. So that tells you that the incoming current should be equivalent of outgoing current, right? So let's say the incoming current, let me take that as a positive, outgoing current we can usually take as a negative at the point O. And similarly the green colors which are incoming will be taken as positive, and the red color which are outgoing current which is taken as negative, right? That turns out to be 0. So if you remove that the product like I2, I3, I4, I can take that to other side. That will tells you indeed it is incoming current should be equal to outgoing current, right? So this is what I am telling. So the incoming current towards the junction, it's taken as positive as we were telling, and outgoing should be taken as negative. No charges will accumulate at any junction. So it talks about the conservation of charges. Alright, moving on to the next law, which talks about the algebraic sum of potential drops. Let's say we have a closed loop. It should form a closed loop. It strictly tells that if you see any closed path or closed circuit only, we have the freedom of using the voltage law or loop law. So that law tells you that if you see any closed path, the algebraic sum of all the potential drops turns out to be 0. Let us see with an example. Let's say we have a EMF which is connecting with a resistor, and we do have another resistance. Let's say we have to find the closed loops. Let's say A, B, C, A, which forms one closed loop, right? And similarly A, C, D, A, which also forms another closed loop. So let's say this is our current direction. இப்போ இதுதான் எனக்கு current direction நான் assume பண்ணுறேன். In order to find, so let's say it is going in this direction. For the upper portion, it is going in the anti-clockwise direction, and the lower portion, it is going in the clockwise direction. So now let us see or form a loop here. So you know, in case of this, I can form a loop A, B, C, A. So if you see, EMF வந்து இப்போ current direction, let me take a pen. So current direction, as we were telling, it is going in the anti-clockwise direction, but ABCA tells you that you have to move in this direction, right? So just a minute, let me take a color, different color. Here the current is actually going in the anti-clockwise direction, but I am going in the clockwise direction, right? So in case of, if you see like this, you first initially you are moving from positive terminal to negative terminal of the battery. So in that sense, you have a negative value. If you are moving from negative to positive terminal, if your direction is something like that, the electric field or EMF turns out to be positive. Electric field, this is EMF. This is taken as positive. If you are going in the another way, it is taken as negative. Is that clear? So once you are moving a path from positive potential to negative potential, EMF is taken as negative, and once you are moving from negative potential to positive terminal, EMF is taken as positive. Is that clear? And here you are moving in this direction, but current is moving in this direction. So because of this, there is a potential rise will be. So because of the potential rise, I am writing this as I1R1. If your path and the current path are same, you have to take with the minus sign, because you see that time your potential drop. If your direction and the current direction are in opposite direction, you have to write with the positive sign, because there is a potential rise over there. Is that clear? The thing is, if you are moving along the direction of the current, there is a potential drop. If you are moving against the potential, if you are moving against the current direction, there is a potential rise. So that is why you have a positive sign here, right? Because current is going in this direction, you are moving in the opposite direction. Similarly, what about this one? So this is also plus I1 I2 times R2, which is turns out to be 0. Shall we? So now let us look for the another loop. So let us assume A, C, D, A. Shall we? So here can you see? your path and the current path are same, so you have to write with a minus sign. And then your path and the current path are same, you have to write with a minus sign. Here you are moving from negative to positive, so you have to write with a positive e. Is that clear? Now I have got a two expressions, so by solving it I can have the corresponding one from another. நம்ம என்ன வேணுமோ அதுல இருந்து எடுத்துக்கலாம். This is the idea of doing any kind of a problem. This is what this law tells us. And the sign conventions, just now before we said EMF is taken as negative when it is moving from positive to negative. Again, if you see from negative to positive, it is taken as positive. And similarly, potential falls along the direction of the current in the current path, and it rises along the direction opposite to the current path. Just now before we said that, right? So I hope it is clear. Potential fall na negative, potential rise அப்படினா நமக்கு பாசிட்டிவா இருக்கும். Now let us moving on to the Wheatstone bridge. So you know, Wheatstone bridge is one of the method or one of the way to find out the unknown resistance. It's basically an arrangement of 4 resistance which can be used to measure one of them in terms of the rest, right? So we do have a 4 resistance here. So in the 4 resistance, let's say current is going let's say in the clockwise direction in the upper part, and in the lower part it is going in the anti-clockwise direction. Just in the A point la junction la padi current enakku piriyudu adudha, right? Now what we are going to do is, again we have to assume the Kirchhoff laws. Let's assume Kirchhoff loop law here. Let's going to consider the loop as ABDA, shall we? So in this loop, I'm going from starting from A, I'm going to end at A itself, but I'm taking from ABDA path edukren. AB, what is the current direction and my path direction are same. I have to write with a minus sign, right? And then galvanometer, you have galvanometer க்கு ஒரு ரெசிஸ்டன்ஸ் இருக்கும், அதுதான் G நான் சொல்கிறேன். கரண்ட் டைரக்ஷன் அண்ட் தென் த பாத், மை பாத் டைரக்ஷன் ஆல்சோ சேம், யூ ஹேவ் டு ரைட் வித் அ மைனஸ் சைன். அண்ட் ஃபார் த தேர்ட் ஆர் ரெசிஸ்டருக்கு எப்படி இருக்குது, இந்த ஏன் பாத்தும் கரண்ட் டைரக்ஷன் ஆப்போசிட்டாக இருக்குது, பொட்டென்ஷியல் ரைஸ் வில் பி தேர். ஐ எம் கோயிங் டு ரைட் வித் அ ப்ளஸ். இஸ் தட் கிளியர்? திஸ் டர்ன்ஸ் அவுட் டு பி 0. Now I am going to see for the another loop which is B, C, D, B, shall we? Here you are moving, let's say B to C. B to C M path current path same, minus sign, right? And then for C to D, my path and current path are different, plus sign. And from D to B, our path and the current path are different, again positive. Is it clear? You can make that equals to 0. Now I am going to solve this. எப்படி இதை சால்வ் பண்ணலாம் அப்படின்னா, ஒன்ஸ் வந்து எனக்கு ஐஜியில் வந்து கரண்ட் போகலை அப்படின்னா பிரிட்ஜ் வந்து எனக்கு பேலன்ஸ்டாக இருக்குது அப்படின்னு அர்த்தம். எப்போ எனக்கு கரண்ட் போகாது அப்படின்னா, ஐ டெல் யூ ஒன் கண்டிஷன், ஒன் கண்டிஷன் இருக்கும் போது மட்டும்தான் இந்த ஐஜியில் வந்து எனக்கு கரண்ட் போகாது. ஐஜியில் கரண்ட் இல்லை அப்படின்னா தட் கண்டிஷன் இஸ் கால்ட் அஸ் அ பேலன்ஸ்ட் கண்டிஷன். எப்போ இது நடக்கும்னா, பொட்டென்ஷியல் பிட்வீன் பி அண்ட் டி, potential between B and D எனக்கு சேமாக இருந்துச்சு அப்படின்னா there is no current through the G, right? Will you agree with this point? So that condition is called as a balanced condition. By manipulating, just by substituting in this above equations, we will have in the ரெண்டு equationல நீங்கள் IG 0 போட்டிங்க அப்படின்னா just you are getting IP by Q which is equivalent of R by S. This condition is called as a balanced condition. Once you have a Wheatstone, this is a picture or like this is a இப்படி இருந்தாலே it's a Wheatstone bridge அப்படி நம்ம சொல்கிறோம். ஸோ இந்த Wheatstone bridgeல நம்ம P by Q which is equivalent of R by S இருந்தால் in between இருக்கிற resistance you can remove because the potential same, there is no current which flows, there is no current flows through the galvanometer. This is what I am trying to tell. Is that clear so far?